Hello students, in this video we'll discuss the axioms of a probability. A probability function is a map which takes events and events are subsets of a sample space so that is the input. It takes in events, so you're going to input in events to a probability function, and outputs a number between 0 and 1 with the following conditions, such that the first condition is that the probability of the entire sample space as an event is equal to 1. Second condition is that if I look at the probability of a union of events, E1 union E2 union E3 union En, going off potentially forever, that this will be the sum, j goes from 1 to infinity, of the probability of Ej if, and this is an important if, Ei intersect Ej is the empty set for all I and j, for all I not equal to j. This means that these sets are pairwise disjoint. So there's no common overlap between any of the sets at all. They're disjoint sets. So if you want to find the probability of a disjoint collection, it's the sum of the probabilities of the individual events. So let's see an example. And the third condition is embedded in this definition. So it outputs, its range is a number between 0 and 1. So I've embedded the other condition in this definition over here. And so what that means is it means that if we want to write down a third condition to be redundant, you would say the probability of an event is always trapped between 0 and 1. It can't be 1.5, it can't be -6. So the probability is always between 0 and 1. So let me write down some examples of a probability. So here's an example. And we'll encounter this example a lot later. I'm going to consider an event, so let's let n be the number of customers at a restaurant at a given day. So what can happen? So n can be equal to 0. And let's call this event over here that there are 0. We'll call this over here E sub 0. N can be equal to 1. There could be one customer. Let's call that E sub 1. And actually, n can be any number, theoretically. N can be equal to k. We'll call that ek. And what we'll do is we'll define the probabilities of these events happen in the following way. I'll claim this is a probability measure, or probability function. So I'll define on this space the probability of ek will be e to the -5, 5 to the k, over k factorial. Later we'll see this is a Poisson random variable for n. And so we have to check that all these conditions are satisfied. Well, clearly the probability of the whole space, is the probability of E0 or E1 or etc. forever, because they're disjoint. If n's equal to 0, n can't be 1 or 2 or 3 or 4. And what this is, since these are disjoint, we'll see this is the sum. K goes from 0 to infinity of e to the -5, 5 to the k over k factorial. So we can pull that e to the negative 5 out. And the sum, k goes from 0 to infinity of 5 to the k over k factorial. And now we recall that the definition of e to the x is the sum, n goes from 0 to infinity, of x to the n over n factorial. And so this over here is exactly just e to the 5th power. So this is e to the 5th power times e to the negative 5, and that's equal to 1. So the probability of the whole sample space is equal to 1. And since all of these events are disjoint, we can see that the second condition is trivially satisfied. And all of these numbers over here, since the individual sum converges to e to the 5th power, are all less than 1. So this defines a probability on this space of events. Thank you very much.